All right. Hello, everyone. Thank you so much for being with us today. Thank you for waiting this almost a minute. And so, without further ado, I think that we can start. So, welcome again. Thank you for joining us. And we are thrilled to have you with us today for a live webinar, this time about the 2026 Tech Playbook predictions, challenges, and tactics for startups. My name is Yoav Marcus, as you can probably see here, and I'll be your moderator for today's session. So whether you're dialing in from the UK, Europe, or elsewhere, thank you for taking the time to be with us today. Our experts driving today's session are Maish Saidel-Keesing, Senior Developer Advocate at AWS. Hello, Maish.
Hello, good afternoon, everybody. How are you all?
Thank you so much for being with us today. And last but not least, it's Nir Shney-Dor, Director of Solutions Architecture and AI ML at Automat-it, and soon to be promoted to VP. So congrats for that as well.
Thank you very much. Appreciate it.
Welcome. Welcome. Thank you so much also for you for being with us today. And so right before we'll kick off and start with the professional part of this webinar, please allow me to remind you that the session is recorded in order to share it with you alongside the other registrants that couldn't be able to join us today. And it's important to let you know that we will leave time for a live Q&A part, so get your questions ready and make sure to type them only in the dedicated Q&A field, which appears in the bottom, not in the chat. Please try to avoid from typing your questions in the chat. And also, we'll be raffling off a $100 Amazon gift card to one lucky attendee towards the end of the webinar in the last few minutes. So now, I think almost after 5 minutes, sit back, stay curious, and feel free to drop questions as we go. And let's get started. Over to you, Maish.
Thank you very much. Can everybody see the screen properly? We're good. Okay.
Yes.
So, as we all do today, I generated this image with some kind of prompt in my terminal. And the reason I did it, of course, is because I'm not an artist. And I wanted to kind of portray an idea of the world is changing. And we're at the beginning of 2026. So I wanted to talk to you today about the autonomous revolution and how you can actually prepare for this. My name is Maish Saidel-Keesing. I'm a senior developer advocate with AWS. Thank you, of course, Yoav and Nir for hosting me here today and inviting me to participate. And let's dive straight into what we're going to be talking about. We're going to be looking at three different trends for the year 2026. First one is of how we need to understand more about our applications. The second one, we'll talk about autonomous agents. And last but not least, why Gen AI should not only be for developers, but should be adopted by everyone. So let's get started. I'm going to make a statement which might feel a little bit weird, but I think it is true. But most probably for most companies and developers which are building things today, you're flying blind with your Gen AI applications. And what I mean by that, you've deployed your application to production and it's handling real customer data. And what can you actually see? You only actually see maybe the CPU usage, memory consumption, maybe the response times. It's pretty much the same metrics that you've been tracking for years. And there's nothing wrong with those metrics, but they're just not enough anymore. Because in the meantime, while you're running your application today, there on your production system, your multi-agent workflow is just, for some reason, failed at step 3 of number 7. And your LLM is hallucinating in maybe 15% of your responses for some reason, and you're burning through your token budget 3 times as fast as you actually expect it to happen. And my question to you all is, do any of you know about those problems today? I assume that most don't. If you do, then you're in a very, very good shape. But most customers that I speak to, they complain. Your customers complain because your application is not working correctly, but we don't actually know what is happening with inside our applications. The problem is traditional monitoring was built for deterministic systems. And when we're talking about systems, a lot of the systems today, they are not necessarily deterministic. It's multi-layered, it's constantly evolving, it changes. And the tools that you're currently traditionally using to keep your microservices healthy cannot actually tell you if your AI is actually working. So here's what you actually need to see. There are 4 critical dimensions that I want to emphasize here today. The first one, and again, these are critical dimensions. It's not a good idea to run your production Gen AI application without actually your visibility into all 4. So the first one is performance. How fast is your application responding? But here's the catch. It's not only about the response time, you actually need to see where the time is being spent. Is your inference taking 3 seconds, 7 seconds, 1 second? How long is it taking for that vector database lookup when I'm running my query? Is the API orchestration layer adding an extra second? Without this kind of breakdown of the specific performance, you're just looking at a number that says it took 6 seconds, but you don't actually know where it is without understanding the application, and you don't know how to start optimizing this. The second one is a cost per request. Every API that we use today, specifically with Gen AI applications, has a price tag. Yes, token cost, compute costs, storage costs, they all add up. And without the visibility, you're pretty much flying blind on your burn rate. You don't know, am I spending 2 cents per my request or $2? It matters when you start getting into scale, when you have 1 million requests a day. This will add up on a very, very significant scale. The third dimension is the quality and accuracy. And this is actually the hardest one to measure, but it is the most important. Is your application or your AI giving you the correct answers? Or is there some kind of hallucination or something which is not accurate? The traditional metrics of an HTTP 200 response will not tell you if your content is actually useful, even if your content is actually true. Your monitoring dashboard might be green when your AI is confidently imagining and making things up. That's something which you have to measure as well. The fourth dimension is bottlenecks. And you need to identify where your bottlenecks are. Is the bottleneck the prompt engineering? In other words, what you're asking from your LLM, or the capacity of a model, or a query from a database or network? You need to be able to pinpoint the exact failure in your multi-step workflow. Because with a system that has multiple components, something is not working is just not enough for you to actually understand what's going on. So this is what makes it actually really challenging. These 4 dimensions are connected very, very well together. They're interconnected, and that's a problem because you can't optimize one without actually affecting the other. Faster responses might mean that you lower your quality. Better quality might increase your costs. And the traditional monitoring tools that we mostly use today show you these in isolation. But when we were talking about observability in Gen AI applications, this requires seeing them all together. So let's dive into why this is also complex, and one of the biggest challenges I think most of you are facing today. Let's have a look at a multi-agent workflow visibility, or maybe say a complex multiplier. When you move from one single AI agent to multiple agents which are collaborating with each other, your observability complexity doesn't only increase, it kind of explodes, and with multitudes. Each agent performs its own performance, has its own performance profile, its cost structure, its failure modes, and multiply each of those by 1, 2, 3, 7 different agents working at the same workflow. It becomes very, very scary, and sometimes wakes you up in the middle of the night like things that go bump in the night. So let's have a look at a real-world example. You make a call to your agent A. Even the agent A is your research agent. It queries a vector database. It retrieves relevant documents. It passes context to agent B. And it costs 15 cents, for example, the amount of latency was 2.3 seconds, and everything looks good. And agent B is your analysis agent, and it receives that content from agent A, starts processing, generating insights, and then for some reason it timed out after 30 seconds. So your cost here will probably be 45 cents, be its best amount of time. The latency is 30 seconds, and it failed. The third agent which gets that information, which is your response agent, in this case, never received any input because B failed. And the user sees a generic error message. So the cost over here was 0, the latency not relevant, but the user experience for your customer who had actually asked something, it's pretty much destroyed. So what do you actually need to see? First, you need end-to-end tracing. That will need to be distributed tracing for your AI workflows. In other words, each and every single one of them, like you have your microservices, but in this case, it has to be adapted for LLM calls, token usage, and probabilistic outputs. The second is visibility into the handoff between agents. What data is being passed through them? Is the context being preserved? Are agents losing critical information? We need to handle. If you don't have that information, you won't be able to debug and get the insight that you would like. The third is failure attribution. When the workflow fails, which agent caused it? Was it a timeout? Was it a hallucination? Was it a malformed prompt? You need to actually know exactly what the problem was. And fourth is the performance bottlenecks. Which agent is the slowest? Which one costs the most? Where should I optimize first? Traditional monitoring shows you that the workflow failed, but multi-agent observability shows you why, where, and how much it cost. But it's not only about multiple agents, it's about multiple models. And what I mean by that, let's talk about the multiple models, what I like to call the multi-model reality. And here's the truth. You're probably using multiple models today, and each one behaves completely differently. The day of using a single LLM for everything is pretty much over because they're not all suitable for all the things. You may be using, for example, GPT-4 for complex reasoning, or Claude for context tasks, Llama for cost-sensitive operations, and each model has a different performance characteristic, a different cost structure, and different quality profiles. So let's have a look what this looks like. For example, we see over here GPT as high quality, relatively high cost, decent moderate latency, and it's good for complex tasks and expensive when you start to get to scale. Claude could be excellent for long context. You can feed it entire documents, variable cost, good latency. And maybe Llama. It's a self-hosted model, lower cost because you're running it yourself, faster latency because it's locally available, and the quality depends on your fine-tuning. But here's the problem. Without unified observability, you're managing 3 separate monitoring systems. You can't compare the performance across models. You can't make informed decisions about which model to use for which task. So what do you need? You need a unified view across all of your models. And this includes, number 1, performance comparison. Which model is fastest for your specific use case? Not a benchmark which somebody else provided or performed. You actually have to test this on your workload. The second is cost analysis. What is the actual cost per request across different models, including the infrastructure costs for self-hosted models, for example? The third is quality benchmarking. Which model produces the best results for your domain, for your users? Not generic, but what specifically is your use case? And the last is failure patterns. Do certain models fail more on certain specific types of requests? This, of course, you will know by trial and error, by running your own tests and benchmarks as well. So let me give you a concrete example. Imagine you're building an intelligent routing system, and the user asks a simple question, and because I know it's a simple question, I can route it to a local model like Llama. It's fast, cheap, and it's good enough. But when the user asks a more complex analysis question, I can route it to GPT-4. High quality, it's worth the cost because I want to give the user a good answer. And when a user provides a 50-page document, I route it to Claude because it's got a long context window. But how do you actually know if your routing's working? You, of course, need to see the performance, the cost, the quality metrics, and all 3 models in a single view. Otherwise, you're kind of optimizing in the dark. So cross-model correlation turns your multi-model strategy from a complex burden into a competitive advantage. But with even perfect observability across your models, there's another challenge you need to solve. How do you optimize? So let me show you something fundamentally that has changed about how we look to think about optimization. In traditional systems, your microservice, your databases, your APIs, these relationships are strong and predictable. Quality to latency, there's some kind of correlation. When I need, how you know the trade-offs. You want better quality, you usually accept higher latency. You need faster response, so you pay some more. You increase the amount of computer resources you're currently using. These are the rules that we've kind of lived for years. You know that correlation. But with Gen AI systems, it is completely different. These bars and correlations completely disappear. Not necessarily when I add more money to my application will I get better quality, cost, or latency. So every optimization assumption that we've relied on up until now is kind of wrong. You can't use your traditional playbook anymore. So that is why you need a comprehensive observability mechanism that shows you all the dimensions simultaneously. Because using Gen AI systems and optimization of the systems, it's not about choosing the trade-offs. It's about discovering those relationships that perhaps you didn't know existed. When one tweak, one item, the other item will change, and how does it actually do? How does it actually modify my application? So how do you do it? In Amazon Bedrock, we have, and specifically I'm talking about Amazon because I work in AWS, but in Amazon Bedrock, we have a built-in observability, which allows you to perform this. In this case, in the first layer, which it happens is there are a number of metrics, for example, invocation count, token usage. These detailed metrics will allow you to actually understand how your application is performing across all those different factors and all those different levels. It's not in this case, for my recommendation, it shouldn't be optional. This is something your foundation for you to build a responsible, scalable GenAI application. The second layer is the invocation logging. You can understand, based on what happened at every step of the way, how the models or the interactions between the different parts of the system are working, including the full context, including the parameters and configuration, metadata, timestamps. This will allow you to dive deep into your application and understand how it's behaving. So how do you implement this? It's a good question. So this is kind of a framework for enabling you to implement some kind of a plan like this. And the first, when it works in the first, I would start by configuring CloudWatch logs for your destination in order to actually accept those logs. For example, also setting up an S3 bucket for long-term storage in order for you to archive those logs and use them over time, and define your retention policies. You create yourself a dashboard based on these metrics and logs in order for you to understand how your application is. And of course, configure some kind of an alarm or an alert to understand when your latency SLA breaches or your number of token requests have gone over your current budget. These are the things you can monitor today with CloudWatch itself. After you've implemented those things and gained more insight from actually collecting the raw data, you can start implementing some more advanced observability models. For example, creating a unified dashboard, maybe enabling more cost metrics in order to get detailed billing in order to understand how the allocation tags works between different applications. And of course, getting some kind of analytics on your guardrails, how your application is performing. Am I limiting the information far too much by the guardrails that I've implemented? And of course, once you've done that, you continue to optimize and scale. You can understand, you can do some optimization on performance, like, for example, prompt caching, which I'm sure Nir will get into a little bit afterwards when he goes into the second part of this webinar. Optimize the token usage, which models you're using. It's not an optional metric or implementation that you should do. These things are crucial for you to understand your applications and how you can scale your applications, deploy applications at scale. The second topic I wanted to talk about is, and this is a quote that I kind of made up a couple of days ago. Your AI agents are not only becoming colleagues, are becoming colleagues today, they're not only assistants. And yes, the world is evolving. And we're talking about autonomous agents. So we're witnessing a fundamental shift in how agents operate. And for the past 2 years, we've been using AI assistants, tools that help you write code. You get thumbs up, thumbs down. Everything is manual, and they're very, very handled in serialization and not automatically. And now we're looking at AI colleagues, which I'm looking today is what we're talking about, autonomous agents. It's become multifaceted, things which are more autonomous and things which move a lot faster. This metric of 99% is a goal which I hope we all can aspire to and one day, hopefully, as much as possible, accomplish. And when we get to 99% of, I can say that my application is reliable, I can start really thinking about using autonomous agents. So autonomous agents are changing the game. It's not a concept. They're all already transforming these the way we work. For example, an application, for example, of workflow orchestration. You have an autonomous agent which moves through the different stages, hands over the workload from one pass to another. All of this done without any human interaction whatsoever, just intelligent orchestration from start to finish. Another one might be, for example, customer service. Customer contacts you, provides a problem. The autonomous agent will start researching the problem, providing an answer, and provide update a refund, for example, update the billing information if it needs to. All these things can be done automatically with autonomous agents, and this saves you money with the number of requests that your customer assistants can handle, how fast they resolve, and how much more your customer satisfaction improves. Another example might be a supply chain. Your autonomous agent might recognize there's an impacting weather event and start making all the changes automatically. Move items from one site from one place to another to make them more accessible if they need to, update the customer, reroute shipping, update production if they need to, and reallocate inventory. All these things can be done by an autonomous agent. So there's a critical threshold that separates AI agent from AI colleagues, and it's all about the reliability. There's a certain line. And what does it actually mean? So today, mostly the AI agents that we're using are supervised as manual intervention. We are aspiring to get to the more autonomous operation. And for me, that line is at 99% when I can rely on almost with full certainty onto what the AI is going to be doing. And how do we do that? By incorporating advanced reasoning capabilities into the applications itself. It allows more multi-step logic to think and improve handling of situations that might not be so clear. The second, we have memory systems, which provide long-term retention, better context management, and persistent learning. And number 3 is error detection and self-correction. Real-time confidence, which is storing automatic understanding of the validation and error prevention. And we have a standardized safety framework, which has in the industry best practices. And this allows you to move from the left side of the table to the amazing right-hand side, which is more scalable, reduce your costs, use more board use cases. And how do we do this? By using standardized safety, where every action is validated before, during, and after execution. We run scoring on these applications. The agents report certainty levels. Low confidence triggers more automatic review or extra checks on the system. We have action boundaries, clear limits on what agents can do. And we have escalation protocols where we understand where we need to actually involve a human in the loop for high-risk actions, and we continuously monitor. And with this, we of course also need, in the end, this regulatory compliance, which has a governance model with technical guardrails and also with operational policies and human oversight when it's actually needed. The safety frameworks are not constraints, they're enablers. They will enable you to gain more confidence into your applications and drive forward. The shift from AI assistants to AI colleagues isn't the flip of the switch. It takes time. It's a deliberate journey. So here's kind of a roadmap. Firstly, you start running with what we call supervised autonomy. This is where you build confidence. You have your applications where you understand which are specific use case, and you start running and you pick one narrow, well-defined pilot. And the success will be your pilot is working, you have a baseline, and everything in the stakeholders are confident. As you go further in time and gain more confidence, you look for conditional autonomy. You look for the applications where there's low-risk decisions, still maintain human oversight when there needs to be, and you can continue to evolve and integrate additional context in different applications. And as you go further and further in your journey, you can gain more confidence, go to full autonomy by providing an enterprise-grade reliability and scale across your organization, amongst other things as well. The last point today I want to talk about is the infrastructure gap. And this is about DevOps engineers or SREs or operational engineers, whatever you might call. Most developers today have adopted Gen AI tools, but not, I think, in my eyes, DevOps engineers, because a lot of their use cases are repetitive daily things which rely on manual processes. And I think today that what we should prepare is these kind of processes are very, very ripe for automation and using Gen AI tooling. So let me show you how this starts. For example, this starts with, of course, considering or accepting your AI agents as first precedence. But you also, of course, have to have RBAC, remote role-based access control, which defines what your agent can do. The second thing you need, of course, is resource quotas. You can't allow your agent to jump to wherever it would like and do whatever without actually putting in some kind of guardrail or safety. The third thing is you need a governance framework, which provides you to audit whatever is going on. And last, of course, is identity management. Agents have persistent identities across systems, and you need to monitor what they're allowed to do and control those. So a real-world example, we have a certain agent, which might be a monitoring agent, which only has read access, and this is defined completely different from your deployment agent, which has full access. The agents might be limited on how many resource quotas or how many applicant or how many requests they can act per second. You need the audit logs, which exactly understands what the application did. And the identity management, which allows you to say that this agent does not have access to production, only to development systems. Once we do this, we can go into the more we call autonomous infrastructure management, where here we have the DevOps teams and the tools that they're using provide more and more benefits to our companies with predictive management, self-healing systems, patch management, which is done in an intelligent way based on downtime, and of course, autonomous incident response. When something happens, the system can kind of fix itself. It takes a certain amount of maturity, but this is possible, and I have seen customers and know customers that are doing this on a regular basis. And how do we have these kind of platforms? A predictive intelligence where we have workload forecasting, failure prediction, cost optimization, and of course, performance prediction. A second capability might be the adaptive behavior, where we have your applications know where to run. I know where to choose which model based on the specific behavior of my application, maybe the time of day, and maybe the month of the year, based on the different price changes within the different architecture that you are using. And of course, based on all those things, the system can optimize itself. It changes configs, it changes prompts, it optimizes prompts in order to improve the application and make ourselves more nimble and more optimized. Sorry. So the infrastructure of teams for 2026 will not be fighting fires. They'll be building intelligent, self-managing platforms that scale effortlessly across any kind of environment. Today, we talked about 3 different trends about how to understand what your application actually, how it behaves. Secondly, the fact of autonomous agents, how you will be able to offload more and more work to your agent. And of course, how we should allow and embrace the fact that agents should adopt these tools, not only developers, but also the people which are monitoring, operating, and maintaining our systems. My name is Maish. My details here are on screen. You can, of course, if you would like to get in touch with either Nir or myself, scan the QR code on the screen as well. We'll be happy to get back to you if you would like to have any questions after the end of the webinar. And I apologize, Nir, I stole 2 minutes of your time, but I'm going to hand it over to Nir as well, that he can continue with the second part of the session.
Absolutely, will do. Okay, can I take over?
Yep.
Great. Maish, can you see my screen? Just to make sure.
Yes, I can. Thank you.
Okay, so hi everyone, and let's talk about 2026. And I promise this won't be another AI is the future deck. We all know AI is here, and Maish has shown it very well. Autonomous agents, the whole shebang. The question is, can your startup afford it when it scales? And this is what we're here to talk about. Gartner predicts that 40% of enterprise applications will use task-specific AI agents by 2026. And that's up from less than 5% in 2025. That's a crazy explosion. Now, here's what nobody tells you. This is going to cost you a lot of money. Agentic AI is going to murder your budget. Believe me, I've been there. And if you don't architect for it now, it's going to absolutely drain your budget. Now, the differentiation game has changed from I have a chatbot, which everybody was talking about in 2024, to now I have a domain-specific intelligence. And also, the European Union AI Act kicks in on August 2026, and there's no more going around about compliance. You have to do it. Now, today, we're going to walk through 3 survival constraints: cost, differentiation, and regulation. And I'm going to show you how to get those architectural patterns in place using AWS and using Amazon Bedrock to let you navigate all 3 without hiring 50 more engineers. Okay, now that I hope that I got your interest, my name is Nir Shney-Dor. I'm the VP of Global Solutions Architecture in Automat-it. Automat-it is a professional services company, a premier tier partner of AWS, focusing only on AWS and startups. We do a lot of complex generative AI, machine learning, DevOps, migration, modernization projects from practically anywhere to AWS, and I'd be happy to talk to you later about this. Now, let's kick this in. Okay, so what's different about 2026? We have three things that are colliding at once. First, we have cost, right? Multi-agent systems that we've discussed previously, those create recursive token explosions. We're talking about where a single user query triggers a planning session, a tool use step, reflection, reformulation, and the final answer. We're talking about more than 1,000 tokens per user interaction. And if we scale to 10,000 daily users, that basically means you're burning through your budget. On premium models, we're talking about tens of thousands of dollars a month. And if you currently don't make any money, that's going to create a very big hole in your budget. Second, we have differentiation. Generic LLM wrappers are now commodity. Every startup has a ChatGPT interface. That's no longer called innovative. And the winners in 2026 are those startups who will build domain-specific language models, or DSLMs in short. Those models encode proprietary knowledge, whether we're talking about healthcare, legal, finance, these verticals demand accuracy the general purpose models simply can't deliver. And if we're talking about moat, or how will my startup survive 2026 when all those giants are coming in, these proprietary data sets are a moat. And if it's not clear, I'd be happy to stay and talk about it. Regulation, compliance, a critical aspect in 2026. High-risk AI systems such as healthcare, finance, HR, and critical infrastructure all require architectural traceability. Now, you need to answer the question, how did the system reach this decision? And we're talking about 35 million euros in penalties or up to 7% of your global revenue if you can't answer that, and that's a huge hit. Those three constraints compound, and you can just solve one in isolation. So let's try and solve all three. Okay, challenge number one. Let me show you the problem. Here's what happens when a user asks you a simple question. Let's say that you've got an input, right? That's 200 tokens. The planner kicks in, another 200 tokens. Maybe database hit, 200 tokens more, reformulates, and guardrails because you don't want to give the wrong advice. That's crazy. We're talking about approximately more than 1,000, maybe even 1,400 tokens per user interaction, times 10,000 daily active users, talking roughly 14 million tokens a day. At the high cost of those premium models, we're talking about $6,300 a month. And if we're going viral, then we're talking about much higher costs. Now, the architectural fix for this is called tiered model strategy. You should reserve the premium models for complex reasoning and use cheaper models for classification and summarization. You can switch 60 to 70% of your traffic to optimize margins, and let me show you how. Okay, so when we're talking about offloading to open models, we're basically talking about using cheaper models for simpler tasks. It's not like you have the biggest hammer in the world and you should choose it for every task, right? You should choose whatever works best for each task. We have in Automat-it a solution called the LLM Selection Optimizer, which helps you choose the right LLM for the right task. And let me show you how that works. Let's say that, for example, you want to invoke Llama 3 70B on Bedrock, not using Hugging Face or standalone server, right? You have your own managed inference. How do you do that? Very simply, you have the SDK, you have the model D, all you have to call is invoke the model. We're talking about a huge differentiation, 86% cost reduction in comparison to other premium models. Now, you're probably thinking right now, it doesn't make sense. I should be using Opus or Sonnet for most things. And the rough truth is that you could be using that, but you would also be spending lots of money doing that. And let me tell you about one of our customers who spent so much money on premium models. We moved 70% of their agent traffic to Llama 3 70B, and this means they went from $18,000 a month to $4,000 a month, giving roughly the same user experience, not 100%, but approximately very good user experience for those tasks, same output quality, and their burn multiple dropped from 2.5x to 1.2x. And this is huge when we're talking about startups who are growing rapidly, maybe tens of percents month over month, and their inference costs are sky high. So think about it next time, and we'll be happy to help you with this. Okay, moving on. So how do we do managed orchestration? Because if you're rolling your own orchestration layer, managing state, recursion, API retries, you're basically creating technical debt that you can't afford. If you want to build custom agent loops, it means that you're managing state persistence, retry logic, timeout handling, and error recovery. That's a lot of engineering overhead. And the solution would be to have Amazon Bedrock agents specifically manage all of that for you. We're talking about doing all the heavy lifting, whether we're talking about state, recursion, API calls, AWS can handle the loop for you. And here's how you define an agent. As you can see, very simple code. All you have to do is to give it a name, pick a foundation model, write some natural language instructions, and you don't have to write any state machine. You don't have to build a queue or set up the DynamoDB. AWS does that for you. So here is what we do. You basically define let's say the topology, and you let AWS execute all of the rest for you. You are basically left with the business logic, and AWS does the rest. If we're talking about invoking agents, you don't need to call the model directly. You call the agent runtime. And here, the application layer calls the runtime, doesn't call the model. You give it a session ID to maintain the conversation state. You pass the user input, and you set enable trace to true. That's really, really important because like Maish explained earlier, you have to give visibility into agent reasoning. Otherwise, you're facing compliance issues. So I'm skipping ahead a bit just to make sure that we're on time, but this isn't optional in 2026. I strongly recommend you turn on visibility and traceability in your AI workloads. Okay, moving on to challenge number 2, differentiation. Now, this is crucial, right? Because today, the commodity trap, as we call it, means that you are just taking an LLM wrapper, using an augmented LLM, and doing something that any big company can do very easily, and you don't create a moat. A moat is where you protect yourself and you create some kind of a unique advantage over other companies. And I've seen that happening with companies who create a DSLM. DSLM is a domain-specific language model that is trained on proprietary data that is hard to get by. Meaning, if you today get those specific data sets from strategic partners that you sign exclusivity with, then your model has a huge advantage over other companies, and that's crucial. In today's landscape, it's really, really important that you think, how do I create a DSLM, or how do I create this mode specifically? So how do I create a DSLM or a LoRa? LoRa is a low-rank adaptation fine-tuning. It's fairly easy to do that on AWS. We're not talking about a huge 10-week training period. We're talking about maybe thousands of dollars in costs and hours or hours or days for some training sessions. But we're talking about fairly a low amount of time where you simply input a JSON-L file. The recommendation is to use many examples. 50,000 is an amazing example. You don't have to get there, but that would ensure a good fine-tuning session. The code to do that is fairly simple. As you can see, all you need to do is to run the fine-tuning session, whether you're talking about legal contracts, medical cases, financial reports. You create a model, and then in 6 to 12 hours approximately, you have a custom model that understands your domain, and now you can swap that into production. Okay, I'll skip a bit faster. Grounding with knowledge bases means that you need to connect models to live private data. you know this as RAG, retrieval augmented generation, but I'm talking about contracts, policies, or internal knowledge bases, stuff that changes, stuff that's proprietary. On Bedrock, it's fairly easy to do that again. You have various options to do it. The example I'm showing here is using a knowledge base, very simple to set up. We're also doing, by the way, workshops where we teach you to do that, and you come up with your own products using your own data. So that's very cool. And the result here would be that you would have some kind of an updated model that has a live data. You don't have to retrain it every time. Okay, now that you've fine-tuned your models, how do you use it in production? Easily, you simply swap the model ID. So let's take a look how that looks like in reality. Instead of the Llama 70B instruct model, you use your custom model A or N. And that would be the same line, same API, very easy. And the result would be an inference that now reflects your specific domain, terminology, and style. This is really important. All you have to do is point to a different model, and there you go, the power of managed AI infrastructure. So code switch easy once the model is trained. It's very recommended if you're in this field. Now let's talk compliance. The European Union AI Act, hovering above our heads, August 2026. We're talking about the enforcement where if you're building AI for healthcare, finance, HR, or critical infrastructure, you're classified as high risk. And in this case, you have to demonstrate compliance, right? You have to show your training data documentation, the disclosure of AI usage. You have to label your UI clearly and provide audit trails, how decisions were made. And the penalties are pretty hefty, as you can see. And the requirement is you basically have to integrate observability and compliance into your workload. So like Maish explained earlier, this is no longer optional, and AWS provides that either with model invocation logging, observability, model tracing, and so on. So we're talking about policy enforcement. How do we do that? You need to block certain content, whether we're talking about PII, hate speech, or simply topics that are outside your domain. You don't want to answer questions about the weather in your app, stuff like that. So basically, you need to decouple safety logic from the prompt or model. You use guardrails for that, right? The guardrails sit as a mesh screen between your user input and the model. And again, it's really, really easy to do that. You define a policy. You can do that on Agent Core, or you can do that on Amazon Bedrock Agents. All you have to do is to choose one of the very simple to implement guardrails that define PII, personally identifiable information, or hate speech, or one of the other types. And then if it's blocked, you return a safe message. Very easy to implement. And also important to know that this is detached from models, right? It's managed centrally, so it is applied across. Okay, runtime safety injection. How do we do that? You simply attach a guardrail config to standard inference calls. Even if the model hallucinates, the guardrail intercepts that. As you can see, again, very simple to do. What I want to say here is that it's really important that you do that, but also make sure that you establish lineage. Lineage is basically tracing, right? So you need to explain how did the system reach this decision. It's not that easy. You need an audit trail to do that. You need to show the chain of reasoning. Which documents did the agent retrieve? Which APIs did it call? What was the internal reasoning? And the mechanism would be to capture and store the agent trace. You remember I said enable trace equals true? This means that you basically write the full chain of thought. And here's how you extract it. So this is the code. You need to basically capture every step the agent took. We're talking about document retrieval or tool calls or reasoning, serializing to DynamoDB or S3. And the key insight here would be to capture agent traces would provide you with a complete auditable lineage of the decision-making process. Okay, so coming up to the big wrap up, what I want to show you here is what would be the future-proof stack as of now, because nobody can predict what would really happen next week in this crazy landscape. But I wanna present a few things. So first of all, orchestration. Agent Core is the platform of choice developed by AWS and is production ready, scalable, and secure, and takes a lot of the heavy lifting. Stuff that we used to do manually before this came out are now easily manageable and definable with a few building blocks. Really easy, very recommended. And of course, we also have a workshop about Agent Core if you're interested. So orchestration. What we want to do here is we usually want to use Agent Core and some kind of an orchestration framework such as Core AI or Agent Strands or LangGraph. For logic and reasoning, you would use tiered APIs, the big models, right, for chain of thought, reasoning tasks, and open models for those easy summarization, task classification, and so on. In domain, you would have those custom models. You would have a LoRa, maybe a RAG to use as a knowledge base. Maybe you would use AWS knowledge base to access both structured and unstructured data sources. This would make your life much more easy. And the governance would be done using the guardrails and tracing in ensuring that your compliance is safe. Now, I want to challenge you as we're coming up to the very last minute. I want to say that if you're brave, you will take one workflow and test it with Amazon Nova. I can almost guarantee that you'll be pleasantly surprised because Amazon Nova is one of the cheapest and most surprising family of models that I've seen. They can do task summarization or text extraction and classification tasks really well at super low costs. And I can tell you that I've worked with customers to achieve that surprisingly well. It surprised me as well. Now, let's talk about the key takeaways, the economics, meaning you need to cap the token costs. You have to maintain differentiation. Don't wrap. Make sure that you have a moat using proprietary data. Make sure that you treat compliance as an architectural dependency. And as for the next steps, run a cost analysis. Make sure that everything is, let's say, fixed and capped. Launch a one-time pilot on Amazon Bedrock. Enable tracing on high-risk workflows, and make sure to be in touch with us. We're here for any questions. We're very happy to help you, as always. Okay, thank you very much. I'll be happy to take any questions.
Nir, thank you so much for this presentation. I appreciate it. I mean, Maish as well.
Sure, thank you.
All right, so I can see already, just in terms of like I'm being cautious of time, so I can see at least one question here. And we'll give it a few more minutes before raffle and wrapping up. So the question is, I think it's for Maish, and it's what tools should DevOps engineer use in order to make more use of Gen AI for their daily use?
I expected a question, and I have to say that it's a typical IT answer. It depends. I wouldn't say there's a specific tool that allows you to move forward with modernizing the way you interact with infrastructure, but you're probably already using some kind of tool today. For example, I like to use Kiro. There's other ones which use GitHub Copilot or Microsoft Copilot, whatever. I don't remember what the actual name is. But whatever tool you're currently using today, use those tools in order to enhance your workflow on a regular basis. It doesn't really make a difference which tool it is. But the thing is to learn the methodology, to use these tools in order to understand your infrastructure, how I can automate things more reliably in a more effective way. It doesn't really make a difference what tool it is. There are platforms which do that, and I'm not going to give a a lift for any of the specific product today, but it's use the tools that you're currently comfortable with, and from there you can move further forward.
All right. Thank you so much for this detailed response, Maish. Another question I can see from, I think the name is Ellie. Is there a document that details the cost breakdown that we can get inspired of to avoid spending high costs?
Nir, do you want to take that one, or should I?
Of course. Ali, thank you for your question. The Bedrock pricing is public, and feel free to, I can browse it real quick and Google it for you. But what I want to say here is that what you should pay attention to, especially, is on what region you're checking. Okay, because first of all, not all models are available globally, and the pricing can be different from one region to the other. So pay attention to that. And when you choose that, when you browse that page, make sure to compare the heavy hitters, like the heavy models versus models such as Amazon Nova or the 4 open models that OpenAI are currently available on Amazon Bedrock.
Thank you, Nir. Another question from, I hope I pronounce it well, Hiten. So Hiten asks, for startups looking to scale rapidly in 2026, what are the biggest hidden architectural challenges you are seeing that lead to unexpected AWS cost spikes, and how can we mitigate them early using automation?
So I'll start, and maybe I'll pass it over to Nir as well, is of course the fact of observability. If you do not incorporate that observability right from the start with your automation and the way you're building your applications, you're going to hit some kind of spike from somewhere where you don't know where it comes from. So I think the biggest architectural challenge is to say, I want to build something quickly and I'll slap on the observability afterwards. That is probably a mistake. When you start building these things, you should initially build it with the observability in mind in order to remove that challenge of hitting these kind of constraints and these challenges further down the road.
So I would like to answer that too. I think that, first of all, that maybe the gut feeling to use heavy models would be wrong for some cases. Second, if you're already using those models, make sure you use caching. You can, for Anthropic Claude models, you can use between 5 minutes and 1 hour TTL window. So that's very important. It shows that you can save up to maybe 70 to 80% of your costs. That's very, very good. Or you can route automatically, again, using Bedrock, between the heaviest models and the smaller models. Specifically on Anthropic, that would be Haiku and Sonnet. Very recommended. And from the architectural perspective, I would say maybe going for older patterns where you don't use managed inference, like managed infrastructure, but you go for GPUs that can be expensive or maybe idle some of the time, misusing the tools that AWS provides. And like Maish said, you have to make sure that Billing Explorer is always, on your mind.
Thank you both so much for this detailed response.